For decades, astronomers believed they understood how the first galaxies were born. They imagined a slow, steady process, tiny collections of stars gradually growing over hundreds of millions, even billions of years. Then a new telescope opened its eyes. Within months, it revealed galaxies so large, so bright, and so mature that many scientists wondered if something had gone terribly wrong. Had the telescope made a mistake, or had our picture of the early universe been missing something all along? Tonight, we're exploring one of the most surprising discoveries in modern astronomy. If you enjoy exploring the biggest mysteries of the cosmos with real science and cinematic storytelling, consider subscribing to Dr. Malcolm. There are many more incredible discoveries waiting beyond the next horizon. To understand why this discovery surprised astronomers, we need to travel almost 13.5 billion years into the past. The universe itself is around 13.8 billion years old. After the Big Bang, everything was unimaginably hot and dense. Over time, the universe expanded and cooled, allowing the first atoms to form, but there were no planets, no galaxies, no stars, only darkness. Scientists call this period the Cosmic Dark Ages. Tiny ripples in matter slowly grew stronger under gravity. Eventually, clouds of hydrogen collapsed, igniting the first stars. Those first stars were expected to gather into small galaxies, simple building blocks that would merge over billions of years into the magnificent spiral and elliptical galaxies we see today. That gradual growth had become one of the foundations of modern cosmology. The James Webb Space Telescope was designed to answer some of humanity's oldest questions. Unlike the Hubble Space Telescope, which primarily observes visible light, Webb specializes in infrared light. Why does that matter? Because the universe is expanding. As distant galaxies race away from us, their light becomes stretched into longer wavelengths, shifting into infrared. The farther away an object is, the farther back in time we're looking. In a sense, Webb isn't just seeing distant galaxies, it's seeing ancient history. When Webb began sending back its first deep space images in 2022, astronomers expected to find tiny, primitive galaxies. Instead, they found something nobody expected. Among Webb's earliest discoveries were galaxies appearing just a few hundred million years after the Big Bang. That alone wasn't surprising. What shocked astronomers was what these galaxies looked like. Many appeared surprisingly massive. Some seemed to contain billions of stars. Others appeared unusually bright and well organized. According to previous models, galaxies this mature should have taken much longer to form. Imagine expecting to find a small village, but discovering a modern city instead. And that's how many astronomers felt when they first examined Webb's observations. Some researchers jokingly called them impossible galaxies, not because they violated physics, but because they challenged expectations. Whenever science encounters something unexpected, the first question isn't, have we rewritten physics? It's much simpler. Did we make a mistake? Astronomers immediately began checking every possibility. Could the galaxies be closer than they appeared? Were the brightness measurements misleading? Had computer models overestimated their mass? As more observations arrived, many of the galaxies remained. Some initial estimates turned out to be too high, but even after careful corrections, enough unusually massive galaxies remained to keep scientists asking difficult questions. The mystery hadn't disappeared, it had simply become more refined. Detecting these ancient galaxies requires extraordinary precision. Every photon of light arriving at Webb has traveled for more than 13 billion years. Some began their journey before our Milky Way even existed in its current form. Webb's enormous gold-coated mirror collects this faint infrared light. Its highly sensitive instruments separate the light into spectra, essentially cosmic fingerprints. Those spectra reveal how far away a galaxy is, what elements it contains, like how rapidly it's forming stars, and even clues about its age. It's one of the most powerful scientific instruments humanity has ever built. Modern cosmology hasn't been overturned. The Big Bang model still explains an enormous amount about our universe, but these galaxies suggest something important. Perhaps stars formed much faster than expected. Maybe early galaxies converted gas into stars with incredible efficiency, or perhaps our computer simulations underestimated how quickly gravity could organize matter shortly after the Big Bang. In science, discoveries often don't destroy existing theories. They improve them. Every surprising observation becomes another clue, another piece of an unfinished puzzle. Astronomers sometimes refer to this era as the cosmic dawn. It's the moment when darkness gave way to light. The first generations of stars transformed the universe forever. They forged heavier elements inside their cores. When those stars exploded, they scattered carbon, oxygen, iron, and eventually the ingredients needed for planets and life itself. In a very real sense, these ancient galaxies are our ancestors. Every atom inside your body was born because generations of stars lived and died before the sun ever existed. The mystery is far from solved. How did these galaxies assemble so quickly? Were the first stars different from those we see today? Did black holes help galaxies grow faster? Or are there still pieces of early cosmic history we haven't discovered? Astronomers around the world continue observing these ancient systems. Each new Webb image adds another chapter. Sometimes it confirms previous ideas. Sometimes it raises entirely new questions. That's the beauty of science. Every answer opens another door. The James Webb Space Telescope has only begun its mission. It is expected to operate for many years. With every observation, it peers farther into the universe's past. Some researchers hope Webb may eventually detect the very first generation of stars, objects so ancient they have never before been observed directly. Others hope to understand how galaxies transform from small collections of stars into the enormous cosmic cities surrounding us today. The greatest discoveries may still lie ahead. It's easy to think of astronomy as the study of distant objects, but in reality, it's the story of ourselves. Every telescope is a time machine. Every galaxy is a memory. Every photon reaching Earth has traveled across unimaginable distances simply to tell us what the universe once looked like. The galaxies Webb discovered remind us that nature is often more creative than our expectations. The universe doesn't exist to confirm our theories. It exists to reveal the truth. One telescope looked deeper into space than humanity had ever looked before. Instead of confirming everything we expected, it handed us a new mystery. Perhaps these galaxies form faster than we imagined. Perhaps our models of the early universe still have chapters waiting to be written. Whatever the answer, discoveries like this remind us why exploration matters. Every time we push the limits of what we can see, the universe has a way of surprising us. And maybe that's the most exciting discovery of all. If you enjoyed this journey through one of astronomy's greatest modern mysteries, don't forget to subscribe to Dr. Malcolm. We'll continue exploring the discoveries that are reshaping our understanding of the cosmos, one story at a time.